So we are given here F sub 1 and F sub 2. So we are required for the magnitude of the resultant force as well as the coordinate direction angles of the resultant force. Okay, so recall that to solve for the magnitude of a resultant force, so we have to add vectorially the forces, the given forces here. So since we have only two forces, so F sub 1 plus F sub 2. The good thing about here, class, is our forces are already expressed in coordinate or in Cartesian vector notation. So it's easy for us to determine the result by just adding the forces and by combining the x component, y component, and z components. Okay, so substituting, class, for our F sub 1, so we have here 60J plus 80K plus your F sub 2 is 50I minus 100J plus 100K. So it's easy for us to solve because both of them have the same unit. Okay, so like we have said, all we have to do is combine the x component, y component, and z component. So for the F sub 1, as you can see, there is no x component, only y and z component. Okay, so therefore, just copy this 50i. So 50i. While for the j or for the y component, so we will add 60 and negative 100. So obviously that is negative 40. And copy the j. This one, 80. So 80 plus 100. So that is positive 180. And then copy the k. And that's it. Copy the unit, which is the pound. So this is already our, by the way, this is the force, the resultant force. Okay. So to solve for the magnitude, so we will simply get the square root of the square or sum of the squares of the components. So fx squared plus frx. This is frx, fry squared, and frz squared. There. So based in our Cartesian vector notation of our resultant, so this is obviously our frx. So square root of, so 50 squared. We have negative 40, so plus negative 40 squared plus 180 squared. There. So therefore the magnitude is 50 squared plus 40 squared plus 180 squared. There. By the way, I didn't put the negative because it will just be the same, because we will going to get the square of it. So 50 squared, 40 squared, 180 squared. So we have 191. Or let's just copy this one to be more accurate. 365. Or if you just want 191.05 pound. 049 actually, or 050, but 0.05 there. So this is already, class, our magnitude. Okay. How about for our coordinate angles, the alpha, beta, and the gamma? Okay, let me first get a copy of this. So F sub R is 191.05 pound. Okay, I will erase this, class. So to solve for the F sub R, Okay? By the way, our alpha, recall that it is arc cosine, or cosine alpha is your fx over f, right? So therefore, we have to base our coordinate angles with the components. Now, if you could recall earlier, the one that written here, our f sub r is 50i minus 40j plus 180k. Is it correct? There. So from here, our x component is this one, y component, and z component, and the value is the magnitude of the resultant is this. So from here, we will be using the resultant because according to the problem, it should be the coordinate angles of the resultant. So we will be using, of course, the values of the resultant, not the force of this, or not the components of this. So solving for the what do you call this, alpha, okay, so arc cosine frx over magnitude of fr. So arc cosine, the frx is positive 50. Take note, absolute value. So 50 over your 191.05 there. So using your calculator, arc cosine 50 over 191.05, we have 74.828 degrees. This is already answer, class. This is already answer. While for the beta, so arc cosine of the FRY over the magnitude. So arc cosine, negative 40, but we have to get the absolute value, so that is positive 40. Divided by the magnitude, so 191.05. So arc cosine 40 over 191.05. So we have 77.915 as answer. And lastly, for the gamma, so cosine of the z component over your f sub r. So our cosine is, we have 180 over 191.05. 191.05 there, 19.582. Okay, so that's the answer. Now let us check if it's correct, class. Okay, if it's correct, can I erase this one? Let us check if our angles are correct by checking using the formula. If you could recall, checking. This is already checking, huh? Cosine squared alpha, cosine squared beta, cosine squared gamma is equal to 1. Okay, so substituting, we have cosine squared 74.828 plus cosine squared 77.915 plus cosine squared 19.582. So it should be equal to 1, ha? Okay, so let us check. So use a grouping symbol. So cosine 74.828, and you have to square it there, plus open parenthesis cosine 77.915 squared plus open parenthesis cosine 19.582 squared. Okay? So it should be equal to 1. Okay, so as you can see, it's 0.99999, 0.99999, or it's already tantamount to 1 kasi we have rounded off our angles here. So this only means that our answers are correct. So again, for this example, this is the magnitude and these are the coordinate angles.